All right, so the probability is a number between 0 and 1. If an event is certain to occur, what would we call that probability? 100%. Or we could say 1. So probabilities are sometimes in fractions, sometimes decimal, sometimes it's in percent. How about if it's certain not to occur? 0. How about if it is equally likely to occur or not occur? 50%. Or 1/2. So the probability that a tossed coin will land heads up is 50%. That's just some of our basics. If you have, there's this chart that just shows you if you want to look back at that. So on the second side of your page, this is the basic thing we do for all probability. It's just the number of successes over the number of possibilities. So if you're carrying 6 folders in your backpack, and your best friend asks to copy your notes from chemistry class, what is the probability that you reach into your backpack without looking and pull out the correct folder? 1 out of 6. So assuming it's a neat backpack with only 6 things in there. 1 out of 6. What is that in decimal form? 16.7%. All right, how many of you are familiar with a deck of cards?
52.
Okay, so about a third of the class. So decks of cards tend to show up in our probability because they're using a lot of games, and that's where people calculate the probabilities. So this is what a deck of cards looks like. So what's that top suit called? Yeah, so clubs. So black cards are clubs. Also black are the spades, hearts, diamonds. And so if I ask you, and I'll try to put this up when you're doing your assignment, but if I ask you, like, what's the probability you draw a black card?
50.
50%. How about a red card?
50.
How about a face card?
What?
So which one of those would we call face cards?
Queen and jet.
Yeah, so how many face cards are there?
25%. 12.
So 12 out of 52, which, what does that simplify to? Anyway,
20%.
12 out of 52, and you type it in your calculator, I think it comes out as like 3 something. All right, so when we have these, remind me to put that back up if we need it. But right now we're going to go just off of the clubs that they gave us here. So if we just have these 13 clubs, what is the probability it's a face card? Which of these are face?
30. Oh, wait, out of these?
Yeah.
0.
3.
King, Queen, Jack. Even though it doesn't draw the face for you, we still have 3 out of 13. What's the probability it's an ace?
0.
1 out of 13. We just have the 1 ace there, right?
Where?
In this set of 13 clubs. Do you see the one that says A? All right, what's the probability it's a club? 100%. What's the probability it's a spade? 0%. Nice and easy, right? Okay, so when you have that, flip to the next page. We're going to take 5 minutes to see if you can do this whole page. 7's the challenge questions. See if you can follow through that whole word problem and get that. The first part should be really easy. Alright, so a female turtle buries 200 eggs in the sand, and in the end they're asking us the probability that your egg hatched. So you picked 1 egg. So what's our number of possibilities? Well, we started with the eggs though.
200.
Yeah, so number of possibilities is still 200. I know 200 didn't hatch, but that's what we start with, is the 200 because we started with an egg. All right, number of successes, we just have to then figure out, hey, how many of those babies actually made it to the sea? So what number do I start with there? Yeah, so 176 hatched minus the 124 who were eaten by birds, minus 37, minus 3. What did that come out to? Yeah, so it's going to come out to 12. So how many baby turtles made it to the ocean? So 12 is the number of successes there. And so then it reduces to 3 over 50, or 0.06, or 6%.
We have to do all of that.
You can pick one format. So, you guys, have any of you been to a sea turtle hatching? I've had some friends, and what they try to do, because this success rate is so low, is like they watch the nests and have people there to help herd the baby turtles to the ocean and keep predators away. All right, flip over to the next page. Maybe at the end of class if we have time. Okay, so this is what we talk about if we're doing two things at the same time. So here we're rolling 2 dice. Fair just means they're not loaded. They're equally likely to land on any side. And so it's already pre-filled for you what the outcomes are. So if this is 1 and this is 1, they're going to add up to 2. If this is a 2 and that's a 1, they'll add up to 3. Or if this is 2 and that one's 1, they add up to 3. So these are just all the different possibilities we could have when we roll 2 dice. This next part is just some basic vocab we have that you might see in your questions about on your assignment. So a random experiment is just anything you're doing. So we could do something like tossing dice, which is what we'll do next time you come into class. We'll do some experimental probability. Or tossing a quarter. So those are examples of two possibilities. If I'm tossing a die, let's say I want to make a 1. And tossing the quarter, I want to make heads. So the way that's represented in our probability language is you do P for probability and then put the result you want in parentheses. So probability I'd get 1, or probability I'd get heads. And then sample space is just all the possible outcomes. So with a dice, it can be 1, 2, 3, 4, 5, or 6. And usually we display those with the brackets around them. For coins, it could be heads or what? Heads or tails. So we have two possible outcomes. So sometimes they just ask how many possible outcomes you have. For the dice up here, how many possible outcomes were there? When we had 2? 36, right? It's just 6 times 6. How many possible outcomes do you think there'll be if we flip 2 coins?
2. 4.
Mm-hmm. And so tree method, it wants us to actually list them all. So if I have the first coin, so say I can tell them apart. So like it's a penny, and the second coin is a quarter, so I can tell which is which. So what could the first coin land on?
No.
Yeah, heads or tails. If the first coin is heads, what could the second coin be? Heads or tails, right? And if the coin is tails, then it could be, if the penny's tails, the second one can still be heads or tails. So that's how we get our 4 possible outcomes. So the 1, 2, 3, 4. Do you guys still need time to write it down? All right, so think back to that picture of the deck of cards we had up there. We did most of these out loud already. What was the probability of drawing a red card? 50%. How about a black card? How about a face card? So 12 out of 52. So what does that become when it simplifies? Oh, is it even asking us? It's not asking us for the probability. It's asking us number possible. So number possible, there's 26 black, 26 red, 12. How many hearts are there? Do you guys remember how many hearts there were? 13, yeah. So the probability becomes 1/4. Bless you. All right, so when you have that, flip to the next page. And so this next page is where we're going to end up flipping back and forth between our chart and back because it's based off of the sample space of the 2 dice. So if we roll 2 dice, and one's red, one's green, so we can tell which is which, what is the probability the total is less than 5? No, sorry, the total is 5 first. So we just come back here, and we could, if we didn't have this handy chart, we could figure it out ourselves, but we could have a 4 and a 1, we could have a 3 and a 2, we could have a 2 and a 3, or we could have a 1 and a 4. So there's 4 possible ways to get 5, right? Did I say that too fast? If someone beside you doesn't have head up, eyes open, and looking this way, would you encourage them to do what they need to do? All right, so 4 out of how many total?
52.
How many total possibilities for the dice were there? 36. What does that reduce to? 1/9. We'll see. You might turn them in at the end of class. And how about the possibility that total is less than 5? So how many of those are less than 5?
25.
Less than 5?
Oh.
6, yeah. So we have 6 out of the total 36, and that reduces to 1/6. How about total is at least 9? Does that mean more than 9 or less than 9? 9 and above. 9 and above. So how many of these are at least 9?
Yeah.
Well, 4 and 9.
11.
I count 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 36. What does that reduce to? 518. Or we could put it in percent if we wanted. All right. So now, again, that deck of cards. What's the probability it's a red card?
50%.
50%. What's the probability it's a 7 or 8? You need the picture again? So 7 or 8? So 8 out of 52. Because we have 2 7 and 8s per suit, so 8, 7 and 8s total. And then that reduces to 2 out of 13. And then the last one on your paper is probability it's either red or black. What's the probability it's red or black?
50%.
Well, 50% for the red card, 50% for black card. So what is it total?
100%.
100%. Any card you draw is going to be red or black if it's part of the normal deck of cards. 2 out of 13 is when that reduces. Alright, then this one is based off of our last one of our diagram of the heads and tails for pennies and quarters. So what's the probability that both are heads? 1/4, because there's 4 possible outcomes and only one was with both. What's the probability that the penny is heads and the quarter is tails? Same 1/4, right? And so if you guys weren't quite following there, we're just looking back here. Okay, both heads is that, penny is heads, quarter is tails is also just one of those options. So now we're again going to take a 5-minute break, and you're going to do this side on your own. Do you guys know what an Old Maid card is? So Old Maid is a completely different game. So what's the probability that you'll get an Old Maid card?
0%.
So if we have the standard deck of cards,
0%.
it'd be just 0, okay, because it's not in that standard deck at all. So that's the thing that confused some of my students. Okay, so this is talking again. Hey guys, one talker. All right, this is talking again about figuring out, hey, what's that sample space? What are all the possible outcomes? So if we have 3 belts, we have a red one, a white one, and blue. They've told us to draw a tree diagram, so I'm doing that. And then 2 hats. So for red, I can go to 2 options for each of these. And so we can have the red belt and yellow hat. I can have the red belt and the green hat. And then white, same thing. And blue, same thing. So if it asks you for a tree diagram, this is what a tree diagram is. You just start with the first one and draw the little branches out for all the other ones. How many total outfits could I make this way? 6. Can you think of any math that would have been faster if it just asked for the number of outfits and didn't tell us to write the tree diagram?
Multiply 3 times 2.
Yeah. And so that's our first counting principle. Makes things really easy. Do you have to draw it or do you have to multiply it? So this one, it said draw a tree diagram, so yes. Most of your problems are just going to say how many outcomes are there, so then you just have to multiply. So here's a rule. Do you guys remember in word problems, usually we tell you and means to add, right? In probability, and means to multiply. Okay? And so if we're trying to figure out that combination, how we can combine this and this, well, there's all those possible outcomes, so you just have to multiply both of them. So we have some word problems here, the probability ones. So suppose you have 5 pair of slacks. Do you guys know what the word slacks means? Yeah, like dress pants. All right, so if we have 5 pairs of slacks and 4 shirts in your closet, how many different outfits can you wear?
20.
20, just 5 times 4. All right, now Janie has 5 rings, 4 bracelets, and 10 necklaces. If she's only wearing one at a time, how many different ways can she accessorize?
200.
200. 5 times 4 times 10. All right, next one is this time it wants us to draw a tree diagram to figure out how many different outfits we can wear if we're only wearing a belt or a hat. So for my belts, I have still the red, the white, the blue. For my hats, I have yellow and I have green. But there's no combinations because I'm only wearing one at a time. So how many total outfits can I wear?
5.
5. So what math happened to get? Yeah, we just added. Okay, and so in probability, when you use that word or, we're doing this or that. It's just an add. So this time we have 5 pairs of slacks and 4 shirts. How many outfits can I do if I'm doing 1 pair of slacks or 1 shirt? 9. And here we're doing a one-topping pizza. So at this pizzeria, there's 5 kinds of meat, 15 kinds of vegetables. So how many possibilities? 20. So 5 plus 15. All right, so flip over. And so what you were going to do now is you're going to do this and come check your answers with me, and I'll check off that you have it done. So you're doing this whole page now. We did that while you were doing that.